All right, in section 3.6, we're going to discuss how to solve logarithmic equations, and so you have your steps listed here. First step is, if necessary, condense to a single log using our properties that we learned back in section 3.4, the product, the quotient, and the power rule. Second step would be to use the log loop to get rid of the logarithm. And then at the end, after you solve, you need to make sure to check for extraneous solutions, because remember that logarithms have domain restrictions, namely that the argument has to be positive. And so if you plug one of your answers back into the original equation and you end up taking the log of 0 or the log of a negative number, that answer has to be thrown out as extraneous. Okay, so we'll start off with a relatively easy one here. Log base 4 of x plus 3 is equal to 2. Notice that I already have a single logarithm, and so I can skip that first step. And the second step is going to be to use the log loop. And so I'm going to start at the base and loop around to the exponent so that I get 4 squared is equal to x plus 3. And then I know that 4 squared is 16, which is going to lead to an answer of 13. Now, if I plug 13 back into the original equation, this is going to say 13 plus 3, which is 16. 16 is a positive number, and so therefore this is an acceptable answer. Okay, here in example B, we are going to have to use the product rule here in order to condense this into a single logarithm, and the fact that there is a plus sign here tells me that it is going to be product rule, and so this is going to say log base 2 of x times x minus 7 is equal to 3. Now you can go ahead and multiply those two things together in the same step if you want to do that. I'm just trying to go a little slower just to show you what's going on. And so now I'm going to move into step 2, which is to use the log loop. So starting at the base and looping around to the exponent, then reading this from left to right is going to give me 2 cubed is equal to x squared minus 7x. And now this is a quadratic equation. So I want this side to equal 0, and I'm going to move that 2 cubed, which I know is 8, over onto the right-hand side so that I have my quadratic set equal to 0. Now, I need a solving method. I think this will factor, and so I would need factors that multiply to negative 8 and add to negative 7, and so I believe that that would be negative 8 and positive 1. And so if I just go ahead and factor this, since the lead coefficient is a 1, I can skip a lot of the details here. And so what am I going to get as my answers? X is equal to 8 and x is equal to negative 1. But before you move on, you need to double check and see if either of these answers are extraneous. And so if you go back to the original equation here and I substitute in 8 for x, then obviously that's going to be positive, and 8 minus 7 is also going to be positive, and so x equals 8 is an acceptable answer. What about x equals negative 1? Well, log base 2 of negative 1 is undefined because I cannot take the log of a negative number, and so therefore this second answer is extraneous. And I just want to emphasize really quickly, it's not the fact that the answer that we got is negative that makes it extraneous. What makes negative 1 extraneous is that when it is plugged back into the original equation, it makes one or more of the arguments negative. And so that's an important distinction to make. I just want to make sure that that's clear. But here in this particular problem, x equals 8 will be our solution, and x equals negative 1 will be extraneous. Okay, here on example C, I noticed that I have logarithms on both sides of the equation. And so what my goal is here is to get a single logarithm on both sides. Notice that I don't have that yet over here on the left-hand side. I have 2 separate logarithms. And once I have one single logarithm on both sides, I can just cancel the logarithm from both sides. And so that's exactly what I'm going to do. On the left-hand side, I'm going to utilize the product rule to make this say the natural log of x times 4x plus 29 is equal to the natural log of 2x plus 7. And so now that I have this in a single log on both sides, I'm not going to need to use the log loop. All I'm going to be able to do is actually rather simpler than that, is I'm just going to cancel the logarithms on both sides. And so on the left-hand side, I'm going to go ahead and distribute. That's going to give me 4x squared plus 29x equals to 2x plus 7. And so once again, this is a quadratic equation. I want it to be equal to 0. And so I'm going to go ahead and subtract over 2x and subtract over 7 and start beginning to solve this. And so you can choose any method that you want as long as that particular method works with this equation. I believe this is going to factor because I would need factors of negative 28, again remembering multiplying those ends to get that whenever that is not a 1, and then it would need to add to positive 27. And so that's going to be positive 28 and negative 1. And so I'm going to come over here and write down my ends. And in the middle have two factors, one with a 28x and the other with a minus 1x. Now, from the first two terms, what can be factored out? I believe we could take out a 4x, which will leave us with x plus 7. And from these two terms, we can take out a minus 1, which is also going to leave us with x plus 7. And so therefore, we have our two factors, 4x minus 1 and x plus 7. Which means we have two answers, two solutions. X is equal to 1/4 and x is equal to negative 7. Now, we need to double check just to make sure that both of these answers will be acceptable. If we plug one of them back into the original equation and get a negative for one of the arguments, then that solution will be labeled extraneous because it will not satisfy the original equation. And so if we start with 1/4, natural log of 1/4 is defined. 4 times 1/4 is 1, plus 29 is 30, and 2 times 1/4 and then plus 7 will also give me positive. So 1/4 is an acceptable answer. What about negative 7? Well, negative 7 makes the very first argument in the equation negative, and that is not allowed. It is a domain restriction on the natural logarithmic function, and so therefore this answer is extraneous. 1/4 is therefore an acceptable answer. Whether or not it's the correct answer depends on if we plug it back in and it actually makes the equation true, which we haven't checked on, but we have checked to make sure that at least it's not an extraneous answer. Okay, one last example where we have to use the quotient rule, and again, because of the minus sign here, I know that's the case, and so this is going to be log base 2 of x plus 2 divided by x minus 5, and then is equal to 3. And so now that I've got that into a single logarithm, I'm going to once again use the log loop. And so 2 to the 3rd power is going to give me 8, and that's going to equal x plus 2 divided by x minus 5. Okay, this is a rational equation, and so therefore I need to multiply both sides by the denominator, and so I'm going to multiply both sides by x minus 5. That's going to give me 8x minus 40 is equal to x plus 2. And then I'm going to solve this linear equation. So subtract x on both sides, add 40 to both sides, and so we get 7x is equal to 42. Go ahead and divide by 7. 42 divided by 7 is 6, and if you plug 6 back into the original equation, 6 plus 2 is positive, and so that's going to be okay. And 6 minus 5 is also positive, and so this answer is acceptable, and it's the correct answer because I know that I solved it correctly. Okay, if you guys have any questions on section 3.6 and solving logarithmic equations, please don't hesitate to reach out, and I hope you guys have a great day.